Today's going to be 62-4, and we're going to take a look at factoring by substitution. And so you guys are going to be able to factor a polynomial or other types of equations by this concept of substitution. So sometimes we're given a polynomial or any type of equation that's similar actually to a quadratic equation. Now, when they look similar, we call this a quadratic type equation. And so it's currently in a form in which we can't do anything to it. And so we're going to use a form of substitution to turn that expression into a quadratic equation. And then once it's in that quadratic equation, then the properties and rules in being able to solve the quadratic equation will work. So on this first example here, notice it says x to the fourth plus 5x squared plus 6 that equals 0. Well, that's not a quadratic equation because this right here, that's x to the fourth power. That can't be quadratic. But what if I substitute a variable? What if I say, let's u be x squared? Well, this x to the fourth is the same as x squared squared. And so if I said u is x squared, well, if I substitute u, I get u squared plus 5u plus 6 equals 0. That's a quadratic equation. And so because that's a quadratic equation, properties of a quadratic equation work. So this will factor. This will factor into u plus 3, u plus 2. Well, we're not solving for u, right? So even if I do say u plus 3 equals 0 and u plus 2 equals 0, we're not solving for u, we're solving for x. So I'm going to have to plug x squared back in. And so now I'm going to get x squared equals negative 3, and then x squared equals negative 2. Now if I square root, I'm going to get x equals root 3i, that's plus or minus, and plus or minus root 2i. So now the first thing that I did here is I substituted in a u for a value that makes the equation into a quadratic equation. Now generally speaking, it's the value that's next to b. So this idea of x squared, if I substitute u in for x squared, that's going to turn this statement into a quadratic equation. So then what I did was I solved, and I got u by itself, right? I did the process of solving for that u once I did the substitution. Then you can substitute the u back in. Now I could have substituted the x squared back in for u here or here, and that's what I did. Or I could have said u equals negative 3 and then substituted it in. And then from there, just make sure you continue solving for the original variable that we had. In this case, that was x. Next one. So I need to substitute u in for the value that makes it a quadratic equation. Now it's generally the value that's next to b. So if I say u equals x minus 3, now this will become u squared minus 2u minus 3 equals 0. So now solving. Maybe I can factor this, so this will factor into u minus 3, u plus 1. Yep. So then that means u will equal 3 and u will equal negative 1. Well, I have to resubstitute it back in, so this is x minus 3 equals 3 and x minus 3 equals negative 1. Add 3 to both sides, add 3 to both sides. X will equal 0 and positive 2. Now it doesn't just have to be like an x squared, like this one. This is x to the fourth. And so with an x to the fourth, that means I'd have to say u equals x to the fourth power. Because this right here, this is x to the fourth squared, which that will make it u squared. So factoring that, you're going to get u minus 9 and u plus 2. Now setting each one equal to 0, right? I have to solve for that variable. So now resubstituting in, I can say this is x to the fourth. I add 9 to both sides, I get 9. And I get x to the fourth equals negative 2. So now taking the fourth root. Ooh, that's fun. This is going to give me x equals plus or minus the fourth root of 9. Well, that doesn't simplify. And then plus or minus the fourth root of 2i. Because it's an even root, just know that you still have imaginary numbers because of that. Now sometimes our values can be a little tricky in this instance. So in this case, x to the negative 1, what if we make that u? Right, I said the shortcut is generally the value that's next to b. So this is going to give me u squared minus 9u minus 10 equals 0. So now factoring this, you're going to get u minus 10 and u plus 1. Now remember, we're still solving, so u equals 10 and u equals negative 1. So now resubstituting the value back in, x to the negative 1 equals 10, and x to the negative 1 equals negative 1. Now this is really weird, right? X to the negative 1, what the heck is going on? Well, that's the same as 1 over x equals 10 and 1 over x equals negative 1. Well, getting x by itself, right, if I want to flip this to the reciprocal, well then this is going to get flipped, which is 10 over 1. It's negative 1 over 1. And so x will equal 1 over 10 and negative 1. Another way of doing that, if I had 1 over x equals 10, I can multiply both sides by x. So I get 1 equals 10x, divide both sides by 10, so x equals 1/10. Same idea. Next one. So this one here, I can say u equals x to the 1/3. So now making that type of substitution, that's going to give me u squared minus 2u minus 8 equals 0. So this is going to be u minus 4 and u plus 2. And so I get u equals 4 and u equals negative 2. Now substituting it back in, so how do I get this 1/3, right? This x to the 1/3. Well, we're going to talk about this a little bit more in the next lesson. But a shortcut when it comes to powers, remember this 1/3 is the same as the cube root of x. Well, the way that we get rid of a cube root is a cube. And so if I cube both sides, now another reason why cubing works is because, remember, I have to multiply these powers. This 1/3 and this 3, I have to multiply those together. Well, 1/3 times 3 gives me 1. Well, that's x to the first power. That means x is by itself. And so I get x equals 64 and negative 8. And that's going to be my answer. So what type of concepts were discussed today? We took a look at u substitution, and we were able to break it down into the quadratic type equation. Go ahead and leave anything else that you thought that you may have learned today in the comments. And in your own, why is it called a quadratic type equation? So I want you guys to go ahead and share that. Why would you think it is called a quadratic type equation? So this does conclude our lesson. If you guys do have any other questions, please leave them in the comments.